Okay, Bob Swanson back again. This is the second video about the Module 9 lab activity. This one deals with eclipsing binary stars, and the first page that we're going to be looking at is, of course, the main page for the Eclipsing Binary Stars lab. Now, this deals with the lab quiz question. So for the first question deals with the location of the center of mass of two stars. In your question, you should see a diagram with star A and star B. It gives you the masses of each of the stars, and the question is, where is the center of mass located? So the best way to approach this question is, again, to go into this first background page in the lab activity. It's entitled Center of Mass, and there should be an interactive popping up, which will allow you to change the masses of two stars, as well as the separation between the two stars. You can click these sliders or enter data into that little data field. And you can choose either to keep your center of mass fixed or click that little radio button off and allow your center of mass to slide around a little bit. But essentially, by playing around with these different mass values and the separation value, you should get a feel for which letter your center of mass will be located at with these two stars with the given masses. Okay, question number 2. Same interactive. You're still on the first background page here about center of mass. This time, they tell you where the center of mass is. They don't tell you what the mass of star B is, but it's still the same game. You're still going to play around with the different masses and figure out what the mass of star B would have to be in order to give you a center of mass at position Y. Okay, question number 3 asks about what a 6,000 Kelvin star would appear like. What would it look like if you saw it from space? To approach this one, your best bet is to go to the second background page, which deals with spectral types of stars. And again, I encourage you to read through the background material, get a feel for what the electromagnetic spectrum is, what these different spectral types are, but you're going to use this interactive at the very bottom. And notice this is an intensity versus wavelength curve, and it shows actually 3 stars. You have a really hot star, a 12,000 Kelvin star. You have a really cool star, a 3,000 Kelvin star, and then you've got the star that we are interested in for this question, which is a 6,000 Kelvin star. And notice that as you change this vertical scale, you can zoom in or get more information about these different types of stars. So right now, when you first pop it open, it's going to show you the 12,000 Kelvin star. Notice this star produces all kinds of light, but it peaks in the ultraviolet. Why? Because it's a really hot star. It produces some visible light, but where it really peaks is in the ultraviolet. And that's because, as you should have learned, Wien's displacement law. The hotter a star is, the farther to the left, or it's the smaller wavelengths, its peak shifts. But again, to get a look at some of the other stars, you just adjust the vertical scale. You pull this slider up, and it will allow us to see in more detail our 6,000 Kelvin star and our 3,000 Kelvin star. And of course, mine's not working right now. But when I'll refresh it and see if I can do it again. But yours will work. You just have to play around with it a little bit and just get a feel for what this star would look like if seen from space. All right, well, you can figure that out. Moving on, the question 4 deals with a luminosity question. You've got a star, they tell you the temperature, they tell you the radius, and the question is, what will its luminosity be? And so the best way to approach that one is to go to the third background page about luminosity. We saw this in the student guide, this animation here, or this interactive, which allows you to change the temperature of the star, allows you to change the radius of the star, and then allows you to compare the luminosity of your fictional star with the luminosity of the sun. That's what remember that those little circles with the dot in the middle, that refers to the sun. So when it says T equals T with the funny looking symbol there, that just means our fictional star has the same temperature as our sun. The radius of our fictional star is twice the radius of our sun. How does the fictional star's luminosity compare to the luminosity of our sun? All right, question number 5 deals with phase. And again, we dealt with this in the student guide, so if you didn't do the student guide, please go back and review that and check out the video that I made for it. The way you're going to get to this answer is to go to the light curves background page, the 4th background page, play around with this animation here, watch these stars eclipse each other, and especially watch this lower right-hand corner box where it talks about this number of cycles and the phase. And if you want to, you can also click this plot data point, and you'll see a data curve show up. Data curve of magnitude versus phase. And it's essentially the same curve that you see in the upper left-hand corner, but whereas that is magnitude versus time, what you're creating is magnitude versus phase. And that should help to guide you to the correct answer on question number 5. All right, number 6 has to deal with what kind of an eclipse you see when a white star cuts in front of a blue star. Best bet here is to go into your simulator. So here's where you can actually open up the eclipsing binary simulator. They tell you the inclination, so you can change the inclination, and you can change the temperatures of your stars, and then just start your animation and see what kind of an eclipse you wind up with. Okay, next question, question number 7, deals with which stars are most likely to eclipse. Well, this one you really have to, again, play with the simulator and figure out what kind of stars would eclipse. You can play with the size of these stars, the radiuses of them. You can play around with the inclination of them and help to determine which stars are more likely to actually eclipse each other. Not all stars, even if they're a binary system, eclipse each other. And a lot of it has to do with the orientation of the plane that they orbit each other versus the perspective of the Earth. So again, you have to think about that one a little bit. Questions 8 and 9 are pretty straightforward. Again, you're going to use the simulator. Essentially, you're going to try to use the simulator to produce light curves that look like the ones that are pictured in questions 8 and 9. What kind of stars would be required in order to produce the pictured light curves? And that's about it. So hope you learned something, and hope this helps. Good luck.